Great, great, great. So let's, okay. Okay, let's get into Intro to JavaScript Part 2. Okay, and everybody can see the slides here, yes? Stop me if you can't see them. All right, so first and foremost, we want to talk about debugging. So debugging is the process of basically figuring out why your code's not working. Developers spend way more time debugging code than writing it. Debugging to me is a lot about like finding the gaps in your understanding of a piece of code, or maybe some assumptions that you've made, or a lot of times honestly just typos. It's a really great way to edit. It's like your editor. So we're going to review some good debugging techniques to help you write better code and go through it more quickly. So the first thing that you can utilize is error messages. When something is off, when something is wrong in the code, it'll throw an error and it'll say things like this on the right: sum is not defined. And it'll give you an error message, and then it will give you what's called a stack trace, which is where the error occurred. If you look to that only odds returns a number block there, you can see to the left of that whole chunk is 1, 2, 3, 4, 5, 6, 7. Those will be line numbers. Each line of code will kind of correspond to a number, right? And we can use those numbers to locate which line each piece of code, each line of code sits on. And so when you talk about a stack trace, you're talking about those numbers there and where they line up to the code you've written. So here we have sum is not defined, and the line gives the location of the error. If we look over to that line 5, it says at only odds. So that's going to be the function that is calling whatever throws the error. And then all the way there to the right, it says only -odds.js, which will be the name of our file, our JavaScript file, and then line 11. So you could go to line 11 and see what might be going on there. The line number is not always accurate. It might not always be exactly what's wrong. You might not be able to always find it there, but you can see where it broke. That line will be where things broke in the code. If you see an unfamiliar error, an error that you're just like, what does that mean? Google it. I do it all the time. It's really helpful. A lot of people use key phrases or words in errors, and we'll just copy and paste it and then create a dialogue that way. So it's really, really helpful to Google stuff. So there's two basic error types. One is syntax errors. There's a misspelling, a typo, a syntactical error. Maybe you were supposed to write var, I don't know, var variable test, right? And instead you wrote variable test var, right? That would be a syntax error. Helpful things to check include that you make sure all of your braces and your brackets and your parentheses are open and closed. So if you have a symbol that's open, make sure that it's has a closing symbol. Make sure that commas, semicolons, arrows, any other symbols are properly used. And also spelling's the biggest one. I like to use like a control find to sort of like go through my code to just make sure that all of my spellings are correct. But yeah, that's syntax errors. The second error is reference errors. So the code is using or referencing a variable that does not exist. A lot of times this is because of something called scope, or like where you've written the line of code might in context to other lines of code that might have something to do here, but it's basically just freaking out because the code will be trying to use something like a variable that has never been brought up before. So the computer's like, I don't know what you want. It's not here. Okay. Any questions about errors or debugging?
So I noticed on the first slide where it actually showed the syntax error, it looked like odds out of the only odds actually starts with a number 0 instead of like a capital O. Is that,
I
or is that
think
just the
just the font.
font? Okay.
Yeah, I think that's just the font being a little confusing. Yeah,
Okay.
I
I was
can see how
just
you'd
making
see
sure I'm
that.
not seeing things wrong
Oh yeah,
there.
yeah. No, I would assume that anytime that you see the name of a variable or a name of a thing, just assume that it's all letters, you know? Cool, good question. Any other questions about debugging or errors? Okay, moving on to conditional statements. So conditional statements control what's called a logic flow in our program. Basically, logic, right, in a lot of ways, like is an ordered and thoughtful way of doing things one at a time, right? Like if we talked about like executing line 1, var num is equal to 3, executing line 2, var num is equal, or var 2 is equal to 5, you know, and do something else and then do something else. You're flowing through the logic of your program. That's like a logical flow. You're doing this thing, then this thing, then this thing. So that's what logical flow is. You can also split your logical flow by the use of conditions, right? Like do a bunch of stuff, do this, then this, and this. And then if this variable is a certain way right now, do this. If it's not, then do this, right? You can start to put pathways or put sort of forks in the road of what your program is going to do based on conditions, based on the state of your program, state of variables or whatever else. So conditional statements allow us to control this flow in our programs. And like I said, you can imagine the conditional statement as like a fork in the road. You can either go this way or you can go the other way. Conditional statements always evaluate to either true or false. So you'll say if, and whatever is in between those parentheses is something that will either become or evaluate to either true or false. So if it's true, do this. Otherwise, do this other code. Here we've got on the right here, right? If true, and so true is a Boolean value already, so we don't even have to evaluate anything. If true, do this, console log, I run this code. Else, otherwise, console log, not this code. So in this case, right, we're always going to hit if true, and that's going to be yes, true, log out, I run this code, and never else log not this code, right? We're always going to skip over that else statement because we have a fork in the road. And in this case, because we have a hard-coded true value, it will always evaluate to true and will always take the true path, the if path. So to write a conditional statement, we can use these if and else keywords. If with an evaluation, or else, all other cases where this evaluation is not true. So if, else, and more. We have if, else, right? We can do if 9 is greater than 8, console log out, this is true. Else, console log out, this is false. So we have a if-else relationship. In this case, right, 9 is greater than 8. So we have this fork, this path that runs off of if true, right, do this. Console log, this is true. Else, if not true, console log out, this is false. So we have a single fork in the road. You can go either one of two ways. There's another option of what we can do, which is the if, else if, and else. So else if is just a secondary conditional statement. We can say if this current number is greater than 8, log out num is equal to 8. So if it's true, we know what to do. Log out num is greater than 8. Else, and now we can put this conditional in here, right? We can say like else, okay, now if it's not true, check this. Is it greater than 6? Is that number greater than 6? If it is, log out num is greater than 6 and less than 8. Else, if it's not true either check, if it's not true on either conditional, we print out num is less than 6. Any questions on that, on conditional statements, or on if, else, if, else, if, else, if, and else? Okay. So we have conditional statements, and then we also have comparison operators. So comparison operators, there's a couple of them. We have the triple equals sign, which is, it checks if two values are exactly equal. Basically, that means that if they're the same value and they're the same type, like the string 1 is not equal to the number 1, right? Because they're different things. One's a string, one's a character, and the other is a number, right? So this triple equals asserts that they both have to be the same type and the same value. We also have the not equals to, checks if two values are not exactly equal. We have the less than operator, the less than or equal to operator, the greater than or equal to. So here are our comparison operators. So Booleans and truthiness. JavaScript has this thing that it does. Remember we talked about how when JavaScript was invented, it wanted to provide ways to keep the program, to keep the browser, keep whatever the web page is telling the browser to do, keep that program running even if some things are not totally correct, right? Other programming languages that are what are called compiled, they have to have all of their I's dotted, all of their T's scratched, like everything's got to be perfect in order for it to run. JavaScript was meant to be a little bit more fluid. You know, you're running this on a shared program on a browser. So it's a little bit different than a traditional desktop application. But anyway, so one of the things that JavaScript does is it does this thing called coercion, where you can change types. If I want to change a number to a string, there's a pretty quick and straightforward way that JavaScript just sort of does that for you. And then one of the big things that it does, as an example of that, is coercing values into Boolean values, coercing the number 1 into either a true or false. And so that's what truthiness is. It's this idea that certain values will always coerce to true, while other values will always coerce to false. So strings that have a length, strings with characters in them, are truthy. This will coerce to true. Any non-zero number is truthy. All arrays are truthy. All objects are truthy. So if I console log out all of these, it will all be true, right? And in this case, I'm using this Boolean function, right? This function that will take in a value and coerce it to a Boolean in order to coerce that value, all these values into true. But all these are truthy values. There are only some specific falsy values. So with this whole thing, it makes it kind of easy. I'm going to show you what the falsy values are, and then you can just assume that everything else that you see in JavaScript is a truthy value. Empty strings are falsy. 0 is falsy. Null is falsy. Undefined is falsy. This thing, non, which stands for not a number, is falsy. So those are the falsy values. Oh, and of course, false. The Boolean value false coerces to false. It is a falsy value. So false, 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 if I log all those out, using that Boolean function here to coerce all the values. Any questions on falsy, truthy, truthiness, falsiness? Okay. So we had that Boolean function, right? And it's really annoying, I think, to write out a word like Boolean like that over and over and over again. So eventually someone agreed with me and they came up with this shorthand way of writing it, which is the bang operator, the not operator, it's also called. The not operator coerces a value to a Boolean value that's the opposite of its truthiness. So if it's true, then it will flip it to false. So this, if I console log that out, it would be false. True is a truthy value. It is true. And then if I put that not operator, it flips to be false. ABC coerces to true. It's a truthy value. And then the not operator flips it to false. 100 is a truthy value. It flips, it coerces to true. It flips to false. An array, truthy, flips to false. An object, truthy, flips to false. So it just flips the value. It flips the truthiness of the value. The double not operator is a way to coerce a value to a Boolean value that reflects its truthiness, right? It's a not. So it's a double negative, so it takes you back to whatever the value is. So in this case, I have true, it flips it to not, it trips, if here I have true, it flips it to false, it flips it back to true. ABC flips it to false, back to true. 100, false, back to true. Array, false, back to true. And an object, false, back to true. Any questions about the not or double not operators? Okay, and then so finally, logical operators. We'll look at and or. What these do, these are used in two common ways. One way is to say, to put up a conditional statement with multiple conditions, right? In order for this whole thing to be true, this and this have to be true. 9 has to be greater than 8, and we have to be coding in JavaScript, or like 3 has to be less than 5 and 1 has to be greater than 0. If either one of those is not true, then the whole thing's not true. The other thing that it does is it returns values. You can use it to put it between two expressions or two values, and it will either return the first falsy value, the first evaluation, the first expression or value that will coerce to false, or the last value if all values evaluate to true, or if they're truthy values. So let's look at this. So we have a variable called returned value, and then we have the number 10. That's a truthy value. Okay, so that would coerce to true. Then we have apples, which coerces to true. Then we have 0. So if I was going to put this in a conditional statement, if I was going to put an if and then all of these things, it would be false, right? Because in order for it to be true with the and operators, it's got to meet all of these things have to be truthy, or all of these things have to coerce or evaluate to true. But what we're doing here is we're taking one of these values, right? That we're not using a conditional statement. We're not using an if else. Here, what we're doing is we're saying, okay, whichever one of these is either the first falsy value, the first value to flip to false, or if all of them are true, give me the last value and I'll store it in return value 1. So like I was saying, like 10 is true, apples is true, and then we hit 0. That's a falsy value. So we would store 0 in returned value 1. If we log out what return value 1 is, it'll be 0. Then we have return value 2, right? We have lucky, that coerces to true, right? It's a string with characters. Same thing for number. Number is a string with characters, so that evaluates to true. And then we have 7. 7 is a number that coerces to true. So 7, right? Because all of them were true. 7 gets returned. It's the first falsy or the last truthy. So now returned 2 is equal to 7. So we have and then we also have or. So in a conditional statement, or is going to say, okay, instead of all of these things having to be true, for the whole conditional statement to be true, if any one of these things is true, then the entire conditional statement is true. So if I said, if 9 is greater than 10, or 8 is greater than 4, that conditional statement would pass. It would say, okay, 9, you know what, 9 is not greater than 10, but 8 is greater than 4. Okay, so one of these meets, one of these evaluates to true, so let's go ahead and pass it forward. The other thing that you can do, like the and operator, is return a value, determine a value from a list of or operators, and it will either return the first truthy value or the last falsy value. So either the first value that evaluates to true, the first value that coerces to true, or the last value that coerces to false. So here we have, again, returned value 1. We have null, right? And we know that null is falsy. It coerces to false. So we go on to the next one. Undefined, we know that that coerces to false. So we move on to the next one. Happy, it's a string with characters. That coerces to true. So the first truthy value, this is the first truthy value, will be picked. So we return happy. We store happy in returned value 1. Now, if I log out what return value 1 is, it will say happy. Then we have return value 2. We have false. We know that that's falsy. Null. We know that that's falsy. Is 10 less than 0? No, that's false. And then we have non, and we know that that's falsy. So we go false to null to that false expression, to non. So we return non. Non is stored in returned value 2. Return value 2, if I console log it out now, will be non. Any questions on those, on logical operators? What about on the entire section here, on the entire lecture, or anything that you would like me to demo? Okay.